let's solve part B now. So we have to add the following constraint to our problem. This is the new constraint. We keep everything else as it was. Now show whether this problem has a solution. Okay, now we have here the graph that we used to have in the previous video. These are the lines. These are the first two constraints that we need to work with. Now let's also draw this new constraint and see what's going to be the area of possible solutions and check if we can get to an answer. Now what is 2x plus y is less than or equal to 26? Let me zoom out to solve this. So it's going to be like that, and we go over here, 2x plus y, so 2x plus y less than or equal to 26. This is a plus. It means that y is less than or equal to 26 minus 2x. 26 minus 2x. We just take this to the other side. Now 26 minus 2x is going to be a line. So let's draw this. Hypothetically, right, the intercept should be 26, so it's going to be quite high. Let's suppose it's somewhere over here. That's going to be 26 on the y-axis. Now the slope has to be -2, meaning that the x-intercept must be 13. And let's suppose that value would be, for instance, somewhere here. It would be very good to have an accurate graph because that's easier to understand and faster. But you know, for the sake of the example, we'll do what we can. So this is going to be the line. This is going to be that line. Okay, we're intersecting these two, right? If we extend them, we would intersect those two lines. Now, what is the area of possible solutions? Well, for these values, right, we must have y values. For this inequality, we must have y values less than or equal to this line. So the values on the blue line are the maximum values that we can have, and we can have less than that. So we can go lower than that, meaning that this would be the highlight of this constraint. Now we go all the way down. Notice that we go only until this level. So when x is positive and y is positive, because that matters. We know it from the previous video that x and y must both be greater than or equal to 0. Now with that said, when we take into account the other constraints, what do we remember from the other constraints? That x minus 4y must be less than or equal to 4, right? So we had, well, where was it? We actually already drew this. We had the area between these two lines, right? Between these two lines. So we're going to shade that as well. We're going to shade the area between these two lines as well. Let's do it with this color, so like that. Now, what do we see? That the intersection is going to give us the possible solutions. So if we take into account the boundaries, right, the constraints, this is the area that has the common intersection. This one like that. This, I don't know how you call this in geometry. It has many sides. But the idea is that underneath this area over here, we might find an actual maximum value because it is constrained. So we should be able to find it. How can we do so? Well, let's see. Let's suppose again that we have a certain value, and let's suppose that value would be equal that x plus y is equal to 10. That's the thesis, right? X plus y is equal to 10. It means, I said 10, I mean 10. It means that y is equal to 10 minus x. So 10 minus x. If we draw 10 minus x, what would we have? Well, let's say 10 would be, for instance, somewhere over here, and we will have the x-intercept equals also to 10 somewhere over there. If we draw it like that, how can we get to a higher value? We must move parallel upwards, right? We saw it in the previous video that bigger values for y, it means that, actually let's do it right now again so that we get this concept really well. If we increase the x plus y value to 12, well, that means that the new line is gonna be 12 minus x. So 12 minus x is gonna look something like that. So it's gonna be this line shifted, you see? So we'll keep shifting lines. Now the question is, until what value are we going to shift? Well, let's see. If we keep shifting, we go until here, for instance. So we keep shifting like that. Now we still can keep shifting until we cross this point, because you see, if we keep shifting until this corner over here, we're still moving parallel. So that's working out, but we're reaching the limit on our constraint, and that's the highest limit on our area of possible solution, meaning that maximum value would be over here. It would be at the intersection of the blue line, which is what was the blue line? 26 minus 2x, and the intersection of this, it was initially, I think, the green line, 2 plus x, right? That was 2 plus x over there. So at that intersection, we would have the maximum solution, meaning that if let's solve it over here, 26 minus 2x equals to 2 plus x, we would find out our maximum solution. So 26 minus 2 is 24, x plus 2x, it would be equal to 3x. So the x value would be equal to 8. The x value would be equal to 8. Now we can substitute this into either of these two lines to find out the corresponding y value over there. And let's say we're substituting over here. Well, 26 minus 2 times x is 26 minus 2 times 8. So that's equal to 26 minus 16, and that's equal to 10. Meaning that the maximum value would be x plus y equals to 8 plus 10. X plus y equals to 8 plus 10, and that would be equal to 18. This would be it. Now, one thing, this is, an additional thing. Suppose that we didn't draw the graph accurately. Suppose that our graph would have been in such a way that, because we're not accurate, we don't care about the slopes. Maybe we would have shifted this line until we get to the other intersection, right? Until we would get to this intersection over here. So visually, we could claim that maybe the maximum point would be there. So just to make sure that, we're doing it right, let's check also on that point, and we'll see that that intersection is gonna give us a lower value. So this is gonna be real quick. That's the intersection of this other line over here, which is minus 1 plus 1 over 4x, right? This line that used to be over there. And it's intersected with the big blue line. And that was the other constraint, which is 26 minus 2x. So 26 minus 2x. Let's solve this. Let's take the numbers on one side. We would have 26 plus 1. That's 27. And on the other side, we would have 1 over 4x plus 2x. Well, that's just 2 1/4, or 2.25x. Now, if we solve the math, what's 27 divided by 2.25? Let's do it right now. 27 divided by 2.25, that's equal to 12. So the x value would be equal to 12. Now, what would be the corresponding y value? Well, let's substitute into one of these. Let's say this one. 26 minus 2x, 26 minus 2 times 12 is 26 minus 24, and that's equal to 2. What is x plus y? Well, x plus y would be equal to 14, and we can see that this is lower than the value that we found as 18, meaning that yes, our graph was accurate. We intersected the right point on our area of feasible solution, so that's our solution. Hope this all makes sense. In the next video we go to part C.